All right, welcome back. Quadratic function review. We'll take a look at this do now. This should be a refresher of yesteryear. You've been factoring since integrated 2, maybe even integrated 1 if you're lucky enough. So pretty basic factoring here. Let's do this. I personally use diamond method to organize my information. I know I'm getting a product of 56K. Just 56, sorry. And then it looks for a sum of 15. So take a moment. Can you think of factors of 56 that add up to 15? Do you got that? Can I count on you to get that? So hopefully you were saying 7 and 8. So +7, +8, these work just fine. Our A term here, A coefficient's just 1. So you can just pop in here and say, hey, it's x plus 7 and x plus 8. Call it a day. It's now factored. Take a moment, try problem 2, see what you can do, challenge yourself, disregard this lag just a little bit longer. It should be able to make its way over there. X squared minus 5x minus, drum roll please, 24. Can you factor it? Give it a moment. Try that out. So I know for sure that one of these factors is going to be negative because we have a negative product. I know that the sum's negative, which kind of plays into a part. You just have to be a little bit more strategic here. I know that because I've looked at this problem while I paused the video, we could look at a factor of 8 and 3. And since we're aiming for a more negative one, let's say that it's -8 and +3. So we could say that factor of 3, factor of -8, x plus 3, x minus 8. Foil it out if you're not convinced, but that works for that one. So we're now given the quadratic function x minus 3 being squared minus 4. So we're pretty much taking x squared and we're deducting 3 from the inside. So taking whatever x is, deducting 3. Think here opposites attract. Where really you're going to be taking x squared and you shift it to the right. How many times? 3. Yep. And then round the outside, think of this as like an elevator. Like, all right, we have our little elevator here and we hit the button to like leave it, to leave our floor. So this is saying we go down 4. And it might help to just redraw out x squared in like, you know, a not as thick line. I think that's a good approach if you need to take your time and kind of think out how this is going to look. So in blue, this is x squared. Draw some arrows because that's going to keep on going and going. We're going to the right 3 times and then down 4. So just take all these points over 3, down 4, plot them. So again, take this over 3, down 4, and you should start to see a formation. We'll worry about those points in a bit, the 5 that we need to show as far as labeling them. But it should be pretty easy to spot. I mean, you're in integrated 3. So what do we got here? You have when x is 1, the outcome's 0. When x is 2, the outcome's -3. When x is 3, the outcome's -4. 4, -3, and also 5, 0. So there you go, 5 points. Let's see a little bit more. So problem 4 is asking, how would the graph of number 3 be different if the equation was pretty much the same thing, but with 2 in the front? It's working twice as fast, so everything's doubling. So it's going to be, you know, like if the quadratic before was like this, it's going to be moving real quick. It took its 5-hour energy. Maybe it had a Red Bull. You could say that it's twice as fast. It's still in the same increments of like to the right 3, down 4, but now it's moving twice as fast. So there you go. All right, so get ready, buckle in, because we're going to give as much information about this quadratic as we can. We have y equals x squared minus 4x minus 12 factored form. as these parentheses and just a different way to write it. So if you factor this, you're looking for factors of negative 12 that add up to negative 4. We can do negative 6 and 2. So the factored form of this is negative 6 and positive 2. Since the a coefficient's 1, we don't have to worry about which x term needs a little bit more. What else can we determine? I noticed that if x was 0, you'd be left with negative 12. So what do I notice? You have a y-intercept at 0, negative 12. Is it a little extra to write the 0 for x? What do you think about that? Let me know in the comments. You can also have x-intercepts where x is 6 and negative 2. So you have x-intercepts where x is 6 and x is negative 2. What else can you determine? You can determine that this opens upwards. That might be, I think this is one of the easier characteristics you could pick up on, but can we agree that this a coefficient is just 1? So that means it's smiling. It's pretty positive. So it's going to be open upwards. It's going to go more and more positive. Is there anything else we could do? Take a minute, maybe think. What else can you determine about this? And I'll sketch out the graph too. So I scaled this, honestly, not super great, but I'm making the most of it. I know that I had that y-intercept at negative 12. I also have x-intercepts where x is 6 and also where it's negative 2. I think we're going to be able to figure out where the vertex is pretty easily. Maybe take a moment. Do you recall this? Negative b over 2a. Do you recall that? Can you find this vertex? Let me know. All right, so the axis of symmetry was a big deal here. My apologies for overlooking it at first, but I still found it. That was good. I had my b term as 4. I had my a term as 1. Remember, you're taking the opposite of b. So before it was negative 4, now it's positive. So I know that I have an axis of symmetry where x is 2. And then if you plug in, you get that x is 2 and y is negative 16. So we have our vertex here. So what else can you determine? You have your vertex at 2, negative 16. If there's anything else you can determine, let me know. You could also have unearthed this point here of 4, negative 12. So there you go. A little bit more that we know about this now. A great rapper once said, what you know about that? This x minus 1 squared minus 9. Going to standard form, that's going to look like this, where a, b, and c are numbers. You can FOIL this out, and don't be afraid to write this out. I'm sure so many of you are going to say that it's x squared plus 1, and that's pretty insane. I don't think I would do that. So you know what? Let's zoom on in and let's see this done, because this is saying x minus 1 squared. So x minus 1 times x minus 1. So that's x squared minus x plus 1. So instead of leaving this, you can just write x squared, combine these negative x's, so negative 2x plus 1, and then don't forget that minus 9 that's here. Don't forget. So then if you take this further, x squared minus 2x plus 1 minus 9. So we're now at negative 8. So are you up for saying a little bit more? Give as much as you can. I'm going to give as much as I can on this because now this is just in standard form. If you could have also derived the vertex from this, shout out to you. But take a moment. What else can you determine just based from this? I was able to say that we had a vertex at 1, negative 9 because, again, this is in vertex form. That's how it was handed to us. Although we went to standard form, you could have also done negative b over 2a. But again, this is just going to kick back that your axis of symmetry is at 1. So you could also say that, I guess, axis of symmetry where x equals 1. If you saw that you could factor this right here, shout out to you, because that can then kick back what your x-intercepts are at 4 and negative 2. You also have a y-intercept at -8, which again was detailed here in standard form. So notice how it's only in standard form we can really say what our y-intercept is clearly. If it's in vertex form, that's a different story. I feel as if this is a pretty good list of things we know. So I hope you were able to come across some of these, most of these, hopefully all of these, and maybe even more. If you got more, tell me. Would love to hear about it. A great poet once said, looks can be deceiving. I think they said that. I don't know who said it. I'm sure a poet did, though. We have something to look at here with this graph. We get this graph. It's quadratic. So we know that. We are able to say a little bit. I mean, there's some points here. Notice how this is incremented. It's jumping from 0 to 2, so halfway in between should just be 1. It's also doing the same thing down here. We could aim for vertex form of the equation, but maybe take a moment, think if you can get it. Can you get it? I know that we have this vertex here at 2, -3, and I could just pop in here, opposites attract, say x minus 2 being squared, and then -3. Sorry, the quantity of x minus 2 being squared minus 3. And I might be able to say that that's going to be it. Again, occasionally we have to worry about this a term that's here. But if you factor this out, it's going to kick you what? X squared minus 4x plus 4 minus 3, which matches up with this because it has a y-intercept of 1. So this wasn't asked of you to go to standard form, but you were totally capable. Psych, it actually does ask for standard form of the equation. So there you go. We just did it. You would, again, foil this out. Box method, do whatever you have done before, but do not write x squared plus 4. Do not write x squared plus 4. Put in the work. You are so capable. What else can you determine? Looks can be deceiving, but what's something we can definitely look at and say about this? Take a moment, think about it. So you could probably say things like this. You have this vertex, which we just talked about. We have that axis of symmetry where x equals 2. Y-intercepts at 0, 1, which we already talked about, opens up. There are 2 x-intercepts. I'm going to leave it up to you to find these. If it was me personally, I would probably use the quadratic formula. Or could you do that? I was going to say maybe use difference of squares. Yeah, you might be able to use difference of squares. You know what? Yeah. Or sorry, not even squares. What you can do is you can set this all equal to 0 and then solve it. So if you want to, you could solve that. You know what? Actually try that. Try to solve this and get exactly what those x-intercepts are. Take a moment, solve this, and get those x-intercepts exactly. So, if you scoot this over, you add 3, you take a square root of that, make it plus minus, and then move the 2 over. You have 2 x-intercepts where x equals 2 plus minus square root of 3. So there you go. The whole idea of this activity was to just make sure that you understand how some forms can be rewritten to another form. Some forms show more information about, like, let's say the y-intercept versus the other. We didn't have to deal with any that had the a coefficient like in front of x, but be open to that because it's going to come down the pike. I hope that you found this helpful. Thanks for tuning in. If you were still stuck on anything, please reach out, come to office hours, say something earlier than later. Talk to you soon.